Welcome to the Capital Light Assembly podcast brought to you by Edison Manufacturing and Engineering. Edison is your contract manufacturing partner focused on capital light assembly of complex mobility and energy products. Joined today by a special guest, Chris Timmons from Group14. Chris, thanks for joining the podcast.
Hey, thanks for having me.
Yeah, I'm really excited for this discussion, and this topic doesn't very neatly fit within the title of this podcast of Capital Light Assembly, but really the objective here and the theme is how are innovative companies introducing technologies and scaling those technologies in a capitally efficient or really a financially viable manner so that their technology innovations can have the impact that they're trying to make in the world. And I think within that lens, this topic fits really nicely. So would you mind introducing yourself, Group14, your role at Group14?
Sure. Yeah. So again, Chris Timmons, I'm the VP of Engineering at Group14. So I head up our engineering department on both the production and process side as well as the design side, so the design and construction of our factories. So Group14 is the largest producer in the world of advanced silicon battery materials. And so today, right now, I'm sitting at our first commercial factory in Woodinville, Washington. We're centered in Washington, where we're producing these battery materials for over 60 different customers, representing 90% of the world's battery production. We've also developed a modular approach for really scaling up our production. We're deploying our first two big commercial factories out in Moses Lake, Washington right now. So we're in construction on those, broken ground, concrete's getting poured. It's a very exciting time. Additionally, that same production module has been built already with our joint venture in South Korea. So that's with the SK Group. And so that factory is in commissioning now. These modules output enough material to power about 100,000 electric vehicles. So
very cool. And they output that annually?
Yep, annual output. That's right.
Awesome. And so would you mind just introducing what when you say silicon anode here for batteries, what's the innovation here? How does this play into existing kind of lithium ion batteries?
Sure. Yeah. So the traditional lithium ion battery, batteries have a cathode and an anode, and the anode has typically been graphite powder that a battery maker will take and slurry and then roll that slurry into an electrode sheet, and then that electrode sheet gets cut and loaded into the battery. And silicon has long been touted as a good replacement for the graphite, in that it can hold about 10 times more lithium than graphite can. The challenge has always been that when you cycle the battery, and the silicon can actually swell quite a bit and lead to stability breakdown of the battery. The Group14 innovated a unique composition of matter that it's a combination of silicon and carbon that overcomes that swelling challenge. And so our customers are able to see a dramatic increase in energy density in the battery, as well as improve cycle performance and faster charge rate. So the silicon inherently charges faster than the graphite does. So it's transformational technology in several different ways.
And what is it that Group14 is actually manufacturing? Is it this silicon carbon powder? That's what you're making?
That's right. So it's a powder material. It's a composite of silicon and carbon. And we sell to the battery makers, and in their production lines, they've got these big slurry coaters where they're loading graphite in and mixing it, and they can simply replace that graphite with this material without upgrading or changing the capital equipment in their factory. And then they get a very large, projections up to 50% increase in energy density for their batteries. So
where does manufacturing, and this is going to sound like a simple question to start, but where does manufacturing come into the equation, right? So this fundamentally sounds like it's a chemical innovation, right? This is a chemical company, battery chemistry, right, is what we're talking about here. Mm-hmm. Where does the rubber meet the road for actual production and physical manufacturing?
Sure. Yeah, it's fundamentally a brand new material. Group 14 is a material science company. A product like this has really never existed, and so the manufacturing process is inherently new. There are a lot of pre-existing equipment and technologies we can tap into to gain insights into developing the process, but fundamentally, we're doing this for the first time. And so, just like any other new innovative manufacturing technologies, we need to start, from the early days at Group 14, start on a pilot, lab scale, move that to pilot, do the adequate demonstrations at pilot so that you can down select the appropriate approach to go to commercial, which is where we are now. Yeah.
And I'm sure there's a line here of how much you can say publicly, but can you say much or anything about what actually goes into the manufacturing process of the powder itself?
Yeah, I mean, it's fundamentally we produce a carbon material first, and then we have a compounding process where we compound that material with silicon. And so it's really a two-step process. There's a lot going on in those two steps, but it's fundamentally we produce a carbon material and then we compound it with silicon, and we package it and ship it. So.
And how have you thought about, right, so this is a physical product that allows you to make an impact in the electric vehicle space. The ability for you to deliver for your customers requires you to be able to build and produce at scale with a very high level of reliability and quality.
Sure.
How have you approached, maybe first the question, how did you approach the early stages of,
Sure.
You mentioned kind of the lab pilot and then scaling from there. How did you approach those first couple steps of scaling past kind of the initial proof of concept?
Yeah. So from the materials development process, early stage at Group 14, we focus on manufacturability. And so really a process innovation is almost as important as a technology innovation in some sense.
Mm-hmm.
Because our leadership team, we've been through this before in scaling battery materials all the way from lab up to commercial scale in our previous lives in other industries. And it's really important to look at manufacturability as in your stage gate from early stage. And so when we were starting to develop the process, we were asking ourselves those questions, and we still do this. Now the company's grown and matured, we have a very formalized sort of stage gate development process. In the early days, we were still asking the same questions. What does this look like from a unit cost perspective? What types of equipment could we manufacture this in? What are the types of challenges we would see? So those are questions that we ask from day one. And then moving through from the laboratory and up, we go through a very careful down selection process and for pilot equipment. And that's, we look at multiple different types of pilot equipment. And the key there is making sure you're working on equipment of relevant scale that's going to answer the right questions that you need to answer when you get to the big scale, right? You have to be careful that you aren't being misguided by something that's too small or not quite the right fit to really drill down and give you the answers that you need fundamentally to spec out and down select the right very large scale process equipment.
And how do you go about finding that line, right? Of like, I mean, it's easy from a kind of intuition perspective, say, hey, if this works at this scale, we'll grow up. But then you don't realize that there's these system effects that only come into impact at certain scales, or when you have enough of a volume or whatever. How do you find that balance?
It can be kind of case by case. Oftentimes you get vendor advice. In Group 14, one of our early strategies, so a lot of companies go out for investment with financial investors. We focus predominantly on strategic investors, and that was all of our early investors are, companies like BASF, largest chemical company in the world, ATL, the top producer of consumer electronics batteries. We got Cabot, they make battery conductive additives. Showa Denko, they acquired Hitachi Graphite. Now they're one of the largest graphite anode producers. We were able to kind of tap into a lot to their expertise as well and kind of use them as a force multiplier to help what kind of challenges should we expect? And even down to the point of helping us with some vendor selections for, there's a lot of these battery materials manufacturing equipment. There's a lot of similar vendors and similar types of equipment that's used across the industry. And so we were able to gain quite a bit of insight there. And then there's just chemical engineering know-how, understanding like what are the typical types of problems that you run into in a chemical process like this, and what do we need to be looking for.
And how about maybe a related question? How are you convincing yourselves, your investors, your customers that, and maybe it's easier now that you've already had some scale up in Korea, but kind of that next question of, okay, we've produced at some scale, now we're going to, automotive level scale. How do you convince yourself? And there's a few aspects here, right? Like the product, is the product ready to be manufactured at scale? And there's also the ability, like you guys, the Group 14 team, like, can you actually put together a manufacturing system, system that is going to be able to execute at that scale? And of course, it sounds like you have, right? You have lower volume experience you're pulling on. You have a wealth of team experience, but you guys haven't produced at that scale as this organization. So how did you make that case that, yeah, we're going to be fine and we're going to do this and we're going to excel doing it?
Sure. Yeah. As you mentioned, we are at commercial scale now, so we did get there. It's really, the process itself is it's a very elegant process. It's relatively, and we selected a process that has a pretty wide operating window and equipment that has quite a bit of flexibility and tunability. So it's not you want to have a very large dial to turn with very small adjustments, right? That you can make on that very large dial. And that gives you the ability, as things grow, if you encounter challenges that you didn't anticipate, you have the flexibility already baked into your equipment. It's like, oh no, all this capital is not gonna work. No. You've already baked that in, and you've developed the material that fundamentally has what I would call a very forgiving manufacturing process. And so you've got an operating window that is really quite manageable for this type of chemical manufacturing equipment. And so that it really reduces a lot of your risk. And from speaking to investors, it's easy to kind of explain how you've addressed those risks.
And so that's primarily on the product side, right? And I guess it also, though, speaks to the fact that you guys are thinking about those things proactively, indicates that you have some experience in this space, and you know what you're talking about. But was there anything else, though, of like the case, right? And this is something that I think about often with like just about anyone, right? Of especially a startup coming into a new space, is like, until you've actually produced at a large scale, there is some leap of faith there, right? Because sure, you've done it, and you've done it in past lives, but like in this specific mix of environment, like you haven't done it under this roof or under this name. Was that a problem at all, or is that kind of just a given that you guys will figure it out?
I'd say, in our first couple rounds of investment, we got ourselves to a scale that was very well demonstrated, and we had checked those boxes. But we did move very quickly. So, and we made very efficient use of our early capital, very efficient use of it to give the right demonstrations. So.
Gotcha. Yeah, and so maybe jump to a different topic. So you've already touched on this, but I'd appreciate if you could elaborate a bit. So the battery, this zooming maybe downstream, right, of like the application of your product into the actual batteries. And one of the key questions or challenges in the industry is, okay, can we produce batteries at scale, and can we get the kind of the net energy storage capacity that we need for electric vehicles to continue to grow and scale? Can you speak to why it's so important that this is a drop-in solution as opposed to something that is a complete deviation from the existing infrastructure?
Yeah, I mean, you hear every day about a new, multi-gigawatt-hour battery factory going in somewhere, and there's a lot of money and capital tied up in all these factories. And with supply chains now, lead times for some of this type of equipment are long. I mean, if you're talking about trying to propose a technology where we have to take this whole battery manufacturing infrastructure and change it dramatically in order to make this work, the adoption period for the technology is going to be very difficult and much more challenging. For us, if you got a 10 gigawatt hour battery facility right now, and you adopt our material overnight, you could be up to a 15 gigawatt hour battery factory, right? And so it just, it of course there's qualification timelines and things like that, but you aren't talking about any major capital changes, and that's very significant, both in a cost and timing perspective.
What's the impact at the maybe I'll get there. So sustainability question, right? So one of the key things from a sustainability aspect is like, hey, getting increasingly higher range on a vehicle by simply growing the battery pack, not really a great solution, because we're just increasing the amount of electricity that we need to generate, and additionally making the weight, adding weight to the vehicle, which then makes it less efficient on a per energy unit while driving down the road. And my feeling though is that this circumvents some of these challenges, because you're using the exact same size factor, and I assume there's not a big weight impact. You're just making it so that you can shove more energy into the same envelope. Is that accurate, or what am I missing there?
It's a good way to think about it. I mean, for the same size battery pack, you can get a much longer range, or you could reduce the size of that battery pack and cut the weight of the vehicle, and you have the same range. Right? So the automakers have a choice in how they want to do that. If you're trying to develop a high-performance sports car that you want to be able to have really good control over the weight balance, and you can do that with this type of technology. Additional, electric aviation, for example, we can get more energy for less weight, and that's really important for electric aviation. And as I mentioned earlier, our customers are demonstrating incredibly low charging times with this, so that in a car that helps reducing the range anxiety for the consumer. They can charge the car in under 10 minutes. And for a plane, for example, I mean, the planes are only making money when they're in the air moving passengers or cargo around. If any of that non-productive time sitting at a charging station is lost, so there's a lot of value in the electric aviation space for fast charging capabilities. So.
And is it also accurate to think so? Cathode material sometimes presents some of the challenges from a environmental, also kind of ethical perspective. Is it accurate to think of it as like, hey, you're getting more out of each unit of cathode material out there as well?
Mm-hmm. Yeah, that's right.
So essentially decreases the mining burden.
Mm-hmm. That's correct.
Cool. Well, Chris, this has been, I really appreciate the insights here. I mean, cool work that Group 14 is doing. It's I don't know, at least personally, this closely aligns with the types of innovation that I'm really excited about coming to the industry, and making a direct impact, drop-in impact in a positive direction. So appreciate your insight here on the manufacturing side. What would you kind of leave us with here, or what did we miss? I don't know. Where are you guys heading? Wherever you want to leave a takeaway for someone listening to this.
Sure. Yeah. We're dedicated here to trying to bring about the electrification of everything, and for us to do that, we're wanting to deploy these modules as quickly as possible. And so I think really happy with the way things are going for the industry right now, but we're going to see a lot of changes. And in Group 14, this transformational technology, we want to really be at the forefront of that. Also, right here in Washington State, we have access here to clean hydropower. So these plants that we're building, these things are powered by green electrons, and that's something that we're committed to as we continue to, if we move into other locations and expand. It's a key factor. Really, the carbon footprint of our technology is as important as the technology itself, and we're just continuing to try to push the envelope on that. We're already orders of magnitude better than traditional graphite, for example, but we want to keep going. And we're dedicated, to building a U.S. battery materials and battery supply chain. And so, upstream, downstream, we want to develop these battery ecosystems. And so right now, what's going on out in Moses Lake is incredibly exciting, and we want to kind of look for future opportunities like that to partner and co-locate with, raw material suppliers, and then downstream, battery makers as well, just to try to, build these battery infrastructure ecosystems in the U.S. So
awesome. Well, yeah, I think that's a good place to leave it. Chris, thanks again. Really appreciate it, and best luck to you.
Yep. Thanks a lot. Take care.